July 1937. The air in Leningrad is thick, not with summer humidity, but with a palpable, suffocating fear. On the grand, imposing steps of Leningrad State University, a place of intellectual promise, a 16-year-old girl named Olga Ladyzhenskaya stands frozen. She is a prodigy, a mind already fluent in the language of calculus and abstract thought, a language taught to her by the man now being flanked by two figures in severe dark coats. Her father, Aristarch Ivanovich Ladyzhenskaya, a respected mathematics teacher and a descendant of Russian nobility, doesn't struggle. He carries himself with a quiet dignity that seems to enrage his captors from the NKVD, Stalin's secret police. There is no shouted accusation, no public crime, only the silent, chilling finality of a hand on his shoulder and the metallic click of a car door. Her world implodes. This single, brutal act is not just a family tragedy. It is the deliberate severing of a brilliant young mind from its future. This was the height of the Great Purge, Stalin's campaign of political repression that saw millions arrested, exiled, or executed. The targets were not random. They were the thinkers, the artists, the military leaders, the old guard, anyone with an independent thought or a lineage that didn't fit the new Soviet narrative. Aristarch's crime was his very existence. He was an intellectual from a noble family who dared to teach subjects like formal logic and genetics, ideas deemed dangerously bourgeois. He was arrested and within months executed by a firing squad. The official charge was being a Japanese spy, a ludicrous and common fabrication of the era. For Olga, her mother, and her sisters, the state handed down a different kind of death sentence. They were branded with a label that would cling to them like a shroud, family of an enemy of the people. This brand was a systematic tool of erasure. It meant social ostracism. It meant neighbors who once shared tea now crossed the street to avoid them. It meant friends disappearing, their own families terrified of being tainted by association. But most critically for Olga, it meant the doors to her future were slammed shut and bolted. When she graduated from secondary school with perfect marks, her application to study mathematics at Leningrad University, the very institution where her father had taught and whose steps were now a monument to her trauma, was rejected without consideration. The reason was unwritten but absolute. Her name was on a blacklist. Her intellect was irrelevant. Her potential was a threat. The system was designed not just to punish the accused, but to annihilate their entire legacy, to salt the earth where their family tree once stood. How does a mind like Olga's, a mind wired to find order in chaos and elegance in complexity, process such a profound, state-sanctioned injustice? We can only imagine her poring over mathematical texts in secret, the clean, immutable logic of theorems a refuge from the arbitrary cruelty of the world outside. While the state was rewriting history and reality on a daily basis, the Pythagorean theorem remained true. The principles of calculus were constant. In this world of abstract certainties, she could find a foothold. Her older sisters were denied access to education and forced into menial labor. Her mother, a painter, sold her dresses and possessions piece by piece just to buy bread. The pressure to simply survive, to disappear into the proletariat and hope to be forgotten, must have been immense. Yet Olga held on to the one thing they couldn't take from her, the landscape of her own mind. She was denied a classroom, so she made the world her classroom. She was denied a future, so she began to build one in the only language that could not be censored or controlled. The state had declared her an enemy, but her intellect was preparing for a different kind of battle, one fought on the frontiers of human knowledge. The question wasn't just whether she could overcome this crushing political machinery. It was how a mind, forged in the crucible of such profound loss and systematic oppression, could possibly emerge, not just intact, but powerful enough to solve one of the most notoriously difficult problems in the history of physics and mathematics. The answer to how a mind survives such a suffocating nightmare lies not in a direct confrontation with the state, but in a retreat to a world the state could not touch, the world of pure mathematics. Following that devastating blow and the official blacklisting, Olga Ladyzhenskaya refused to be erased. Through a combination of her mother's relentless persistence and the courageous behind-the-scenes intervention of other academics who recognized her generational talent, a crack in the wall appeared. She was denied entry to Leningrad, but a loophole allowed her to enroll as an auditor at a pedagogical institute. It was a backdoor, a compromise, but it was a start. 2 years later, in 1943, she was finally admitted to Moscow State University, a place far enough from the immediate shadow of her father's execution, where her sheer brilliance could no longer be ignored. After the war, she returned to Leningrad, completing her PhD, under the guidance of the legendary mathematician Ivan Petrovsky. She had clawed her way into the system that tried to expel her. By the 1950s, the global scientific community was locked in a battle with a set of equations that had vexed mathematicians for over a century, the Navier-Stokes equations. These are not merely academic curiosities, they are the mathematical soul of fluid motion. They describe everything from the graceful swirl of cream in a cup of coffee to the terrifying, chaotic power of a hurricane. They govern the flow of air over an airplane's wing, the rush of blood through our arteries, and the vast, slow currents of the ocean. The problem is their staggering complexity. They are nonlinear partial differential equations, meaning that the relationships they describe are not simple straight lines. They are chaotic, unpredictable, and prone to turbulence, that unpredictable, swirling messiness that is so common in nature yet so difficult to pin down with formulas. For decades, physicists used the equations to make approximations, but a rigorous mathematical foundation was missing. No one had been able to prove that for any given fluid dynamics problem, a smooth, unique solution even exists for all time. Without that proof, every computer simulation, every engineering model was built on a foundation of mathematical sand. The Clay Mathematics Institute would later name this one of its 7 Millennium Prize problems, offering $1 million for a proof. This is the intellectual Everest that Olga Ladyzhenskaya, working in the relative isolation of the Soviet Union, decided to climb. While her Western counterparts collaborated at international conferences and enjoyed the free exchange of ideas, Olga worked with a small, brilliant circle in Leningrad. She developed novel methods for solving partial differential equations, introducing new functional spaces and inequalities that provided the tools needed to tame the wildness of Navier-Stokes. In a series of groundbreaking papers, including her 1958 work, Solution in the Large to the Boundary Value Problem for the Navier-Stokes equations in the case of two space variables, she did what others could not. She provided the first rigorous proofs for the existence and global uniqueness of solutions for the 2D Navier-Stokes equations. Her elegant solutions were a monumental achievement, providing the bedrock of certainty that the field had desperately needed. She went on to make significant inroads into the far more complex 3D problem, work that remains foundational to this day. Yet even as her mind was charting these new abstract universes, her body remained a prisoner. The intellectual triumph did not erase the political stain of her family's past. The KGB watched her. They monitored her correspondence. And, most cruelly, they held her passport. Invitations to lecture at Princeton, Cambridge, and Paris piled up, only to be met with cold, bureaucratic denials from the state. We can only imagine the frustration of receiving a letter from a colleague in the West discussing a problem she had already solved, unable to simply pick up the phone or board a plane to share her insights. The Iron Curtain was not just a geopolitical barrier. For scientists like Olga, it was a wall built around the mind. Her work was smuggled out in translated journals, her name becoming legendary in elite circles, yet the woman herself remained a ghost. Who signed those travel denials? Whose paranoia decided that a mathematician was a threat to state security? How could a scientist be tasked with solving the universe's secrets while being treated like a common criminal by her own government? That confinement was real, but the mathematics were universal. Building on those isolated breakthroughs, Olga Ladyzhenskaya's work began to seep through the cracks of the Iron Curtain, a testament to the fact that a truly powerful idea cannot be contained by any political border. While she was denied a physical presence on the world stage, her theorems and proofs began their own inexorable journey. Soviet scientific journals, like the Vola, were meticulously translated and distributed in the West. Mathematicians and physicists, grappling with the same intractable problems of fluid dynamics, recognized the power and elegance of her methods. Her name, once whispered only in the halls of Leningrad and Moscow, began to be cited in papers from Stanford to the Sorbonne. She had provided the rigorous foundation, the logical bedrock upon which an entire field could now confidently build. Her work on finite difference schemes, for instance, became a cornerstone for the emerging field of computational fluid dynamics. She had, in essence, handed the keys to the future of the field to a world that she was forbidden to visit. Today, the ripple effects of her solitary work are all around us, embedded so deeply in our technology that they are invisible. Every time a meteorologist runs a supercomputer simulation to predict the path of a hurricane, they are relying on numerical methods whose stability and convergence were first rigorously proven by Ladyzhenskaya. Her mathematical framework is at play every time an aerospace engineer designs a more fuel-efficient jet engine by modeling the turbulent flow of air over turbine blades. It's there in the models that predict how pollutants spread in the ocean, in the design of quieter submarines, and even in the computer-generated imagery of Hollywood blockbusters that realistically simulate explosions in water. Her abstract, theoretical work, born from a mind in forced isolation, now underpins some of the most practical and powerful technologies of the 21st century. The world was slow to catch up to the woman behind the theorems. For decades, her contributions were known only to specialists. But as the Soviet Union waned, recognition finally began to flow. In 2002, just 2 years before her death, she was awarded the Lomonosov Gold Medal by the Russian Academy of Sciences, one of its highest honors. Posthumously, her legacy has been cemented. UNESCO and international mathematical societies now universally acknowledge her as a titan of 20th century mathematics. The question is no longer she solved the foundational problems of turbulence, but what the cost of her suppression was. We are forced to confront an uncomfortable reality. How much more rapidly could humanity have advanced in weather prediction, in aerospace, in energy, if her genius hadn't been shackled by political paranoia for decades? How many collaborations were prevented? How many synergistic breakthroughs were delayed because she was locked away? Her story is a powerful testament to the resilience of the human intellect, but it is also a chilling indictment of a system that saw a brilliant mind not as an asset but as a threat. It forces us to ask not just about the geniuses we celebrate, but about all the others we lost to history's shadows, their potential extinguished by petty tyrants and broken systems. Remembering Olga Ladyzhenskaya isn't just about correcting the record. It's about recognizing that genius can bloom in the darkest of places, and it is our collective duty to ensure no wall, political or otherwise, ever stand in its way again.